We are given with this data as written here. The linear velocity of blade, that is u, is equal to 10 meter per second, and we know that it is equal to u1 and u2. Diameter of jet is given as 50 mm, and the water that is coming out of jet striking the blade with a velocity 20 meter per second, so that is v1. Okay, and we are given the angle alpha is 20 degree and beta is 130 degree, which is given in the direction of motion of blade. Okay, so this will be 130, and when we will calculate beta, that beta will be 180 minus 130, which will be equal to 50 degree. So this is beta is equal to 50 degree, and this jet is given in 50 mm, so we will convert this in meter. 50 into 10 to the power minus 3 meter. This is the diameter of jet, and we are also given with the without shocking condition. We have to solve the numerical. Okay, so without shocking condition is VR1 is equal to VR2. This is very important conditions, my friend. Okay, so first we will calculate the vane angles, that is theta and phi. Okay, my friends, now we have to calculate theta. First we will calculate theta in the inlet triangle, then phi at the outlet triangle. Okay, to calculate theta, we can use this triangle, and this length is VW1 minus U1, this length. Okay, and this is VR1. VR1 is given as, no, we have to find it out. Okay, VF1 we have not given that, and VW1 minus U1 we are not given that. Okay, now VW1. Okay, so here tan theta is equal to VF1 upon VW1 minus U1. Okay, VFN will be equal to V1 sin alpha. Okay, so this is V1 sin alpha, and VW1 will be equal to V1 cos alpha minus U1. So this can be written as 20 sin 20 degree, 20 cos 20 degree minus 10. Okay, V1 is 20, sin alpha, alpha is 20, V1 is 20, and alpha is again 20 minus U. So here, from here we will get tan theta as 0.7778. Okay, then theta will be equal to tan inverse 0.7778. This will be equal to 37.875 degree. So here we got theta is equal to 37.875 degree. Okay, here is our one vane angle. Okay, now we have to calculate sin theta, which is equal to VF1 upon VR1. So from here we will calculate VR1, as we know VF1 is V1 sin alpha, and here we got theta, so we can calculate VR1. VR1 is equal to 6.84, that is VF1 upon sin theta, that is sin 37.875. Okay, that will be equal to 1.14 meter per second. So VR1 is equal to 1.14 meter per second, which is also equal to VR2. Okay, so we got VR1 and VR2 from here. Now we have to calculate phi from the outlet triangle. Now phi, look at for this triangle. Okay, this is VR2, which we know. This is V2, this is U2, and this is phi. By C, we can see that this angle will be beta minus phi. How? Because this angle will be 180 minus beta. So after applying the angle sum property, we'll get this angle as beta minus phi. Okay, so applying sine rule, we get as U2 is equal to sine beta minus phi, and VR2 is equal to sine 180 minus beta. Okay friends, I hope you know the sine rule, how to apply the sine rule. For this triangle we have applied sine rule. Okay, so we know the value of U2, that is 10, and sine beta is 50, so 50 minus phi. VR2 here it is equal to 11.14 meter per second, so don't write meter per second here, and this is sine 180 minus beta. Sine 180 minus beta is sine beta. Okay, so we can write it as sine 50 degree. So with this equation we can calculate phi, which will be equal to 6.5 6 degree. Okay, after solving this, we get phi as equal to 6.56 degree. Okay, let's move to the second point which we have to calculate. Okay, that is mass of water striking the vein per second, which we have seen as formula in formula as rho A V R1. So rho means density is equal to 1000 and area is pi by 4 d square. D is 50 into 10 to the power minus 3 square into VR1. VR1 is equal to 11.14. After solving this, we will get 28.87 kg per second. This will be the mass of water striking per second. Okay. Third, we have to calculate force exerted by jet in direction of motion. And the formula for this is plus VW2. We have seen that we can generate three formulas from here. One is the changes here as VW1 and plus VW2, and the other is VW1, and the third one is VW1 minus VW2. This formula will be used when beta is acute angle. And here beta is 50 degree, which is an acute angle. Okay, so we will use the force exerted as this formula. Okay, so after putting the values, rho A VR1 we have calculated as 21.87, and VW1 we have to calculate VW1, which is equal to V1 cos alpha, and VW2 is equal to VR2 cos phi minus U2. Okay, after putting the value, we'll get the value of force as 434.36 Newton. We know the values of V1 alpha, VR2 phi and U2. After putting the value, we'll get the force as 434.36 Newton. Okay, now fourth you have to calculate as work done per second on vein by jet. Okay, that is equal to F into U, which is 434.36 into 10, which will be equal to 434.36 Newton per second. Okay, fifth point we have to calculate work done per second per unit mass. Okay, which will be equal to the work done, that is 4343.6 upon mass. Mass is, we have calculated mass as 21.87. So this will be equal to 198.60. Okay. Now if we have to calculate the work done per second per unit weight, then we will use 198.60 divided by 9.81, which will be equal to 20.24 Newton meter per Newton. The unit of this will be, what's the unit of this? This is unit is weight, work done per unit mass. Okay, this is per kg, and work done is force into this. We can write it as joule per kg. Okay, so next, the last and but not the least is efficiency. The efficiency, the general formula for efficiency is output by input. So here the formula will be the work done per second on vein by jet upon the kinetic energy. Friends, we have seen the formula of efficiency. Okay, so I am direct putting the values. It is equal to 4343.6 divided by 1 by 2 half mv square. M is rho A V1. We have seen that why it is V1 and not the VR1. Okay, and then half mv square. So after putting the values, we will find that the efficiency is 55.3%. So friends, this was a type of numerical that may come in your turbine topic, and we have seen every aspects of formula that may be asked in this question. Okay, thank you. See you again.